You ever just look at a can of paint? Seems pretty simple, right? It's just a bucket of colored liquid. But inside that can, there's a whole world of complex chemistry. It's this precisely engineered cocktail, and it's designed to do so much: protect, decorate, and last for years. Today, we're going to pry open that lid and take a look at the hidden science of paint. And that science, it's literally all around you. It's on the walls of your house, the steel of a giant bridge, the body of your car. So what's the secret formula here? What transforms a simple liquid into a coating that's tough, protective, and beautiful? Well, let's find out. All right, we're going to start by taking apart a classic can of oil paint, piece by piece. The best way to think about it is like a recipe. Every single ingredient has a very specific job to do, and getting that balance just right, well, that's the secret to a perfect finish. So every can of oil paint is this really carefully balanced mix. You've got the base, which is kind of the main body of the paint. Then there's the vehicle, which carries everything. You've got a thinner to get the consistency right, a dryer to control the hardening process, and a few other clever additives for special jobs. Let's break down what each one actually does. First up, we have the base. This is the real substance of the paint, the solid stuff, the pigments and fillers. This is what gives paint its color and its covering power, its ability to hide whatever's underneath. It also gives that final dry paint film its hardness, which is crucial for preventing cracks. So, how do you get that solid base from the can onto the wall? That's where the vehicle comes in. Seriously, you can think of it like a delivery truck. It's an oily liquid, something like linseed oil, that carries the base and all the pigments, but it's also the binder. It's the glue that makes the paint actually stick to the surface and form that tough, protective film when it dries. Now, if you've ever used oil paint, you know it can take forever to dry on its own. That's where the dryer comes into play. It's a metallic compound, and you only add a tiny, tiny amount, but it acts as a catalyst. It basically tells the chemical reaction of drying and hardening to speed up, turning that liquid paint into a solid layer way, way faster. We've all been there, right? Trying to spread thick, goopy paint, it's a nightmare. That's why we have thinner, or solvent. It's added to get the consistency just perfect, so you can apply it smoothly. But here's the really cool part. Its job is totally temporary. Once the paint is on the wall, the thinner just evaporates into the air, leaving everything else behind to do its work. Okay, here's an ingredient you have probably never ever thought about. When a can of paint just sits on a shelf, the air inside can cause a solid skin to form right on the surface. Well, an anti-skinning agent is a special additive that stops this from happening. It ensures the paint is perfectly liquid and ready to go the moment you open the can. And you know what? That tiny little additive is a bigger deal than you might think. Without it, it's estimated that about 3 to 5% of all paint would be totally wasted, just hardened into a useless skin inside the can. It's a tiny bit of chemistry that saves millions of gallons of paint every single year. So that's the basic recipe for an oil paint. But paint is just one member of a much larger family of coatings, and each one has its own unique recipe and its own purpose. Let's meet some of the relatives. Let's compare a few of them side by side. So paint uses a solid pigment for color and opacity. Varnish, on the other hand, swaps that pigment out for a clear resin. See, its goal isn't to hide the surface. It's to protect and show off natural materials like wood. And then you've got something called distemper, which uses chalk as a base and water as the carrier, which creates a much softer, more breathable finish for interior walls. Now, even within the world of paint, there's a huge difference between the two most common types. You have the classic oil paint we've been talking about, with its oil vehicle and slow drying time. But most of the paint we use in our homes today is emulsion paint, or latex paint. It's totally different. It uses water as a solvent, and it's filled with these tiny polymer particles. As the water evaporates, those particles all squish together and fuse, creating the film. That's why it dries so fast and has way less of that strong smell. Okay, so knowing what's in the can is really only half the battle. The science continues in how that paint is actually applied to a surface. A truly professional finish isn't just one layer. No, it's a whole system, carefully constructed. It is all about the layers. First up, you have the priming coat. Its main job is just one thing: adhesion. It makes sure the rest of the paint sticks properly to whatever surface you're painting. Then you apply 1 or maybe 2 undercoats. These build up the thickness, they fill in any little imperfections, and they create a super smooth foundation. And only then do you apply the finishing coat, the one that gives you the final color, the sheen, and that durable protective top layer. So what happens when all this delicate science goes wrong? I mean, whether it's a bad recipe in the can, poor prep work, or just applying it the wrong way, the results can be, well, a total mess. Let's look at a few common ways that good paint goes bad. If you've ever seen those ugly bubbles form on a painted wall, that's called blistering, and it's almost always caused by one thing: trapped moisture. Liquid gets stuck behind the paint film, and as it tries to escape, maybe when the sun heats it up, it pushes the paint right off the wall. It's a dead giveaway that the surface wasn't properly dry before painting. Now this one has a fantastic name, alligatoring. And you can see why, right? This crazy cracked pattern happens when your paint layers don't have the same flexibility. If you put a hard, rigid top coat over an undercoat that's still kind of soft and flexible or just not fully cured, the top layer is going to crack all over as the bottom layer shifts around. And finally, the most frustrating one of all, flaking. This is just a fundamental failure of the paint to do its one main job. It's when the paint just peels right off the wall. The cause? Poor adhesion. It means the paint never formed a proper bond in the first place, usually because the surface was dirty, greasy, or you skipped the primer. So we've focused on the coatings we see every day, the stuff on our walls, but the science of protection goes deeper, and I mean literally deeper. Let's finish up with a crucial protective layer that's completely invisible, one that's applied long before a single wall ever goes up. You're not going to believe this, but one of the most important protective coatings a building gets is applied directly to the soil it's built on. It's an anti-termite treatment. This has nothing to do with looks or weather protection. This is a chemical shield designed to protect the entire structure right from the ground up. As our source material puts it, the whole point is to provide the building with a chemical barrier against subterranean termites. So before the foundation is even poured, the ground is treated, creating this barrier that termites can't cross. You can think of it as the ultimate primer coat, one that protects the entire building from a threat you can't even see. So, from the humble can of paint to the chemical shield buried beneath our homes, it's pretty clear that these everyday things are just packed with incredible science. It really makes you wonder, doesn't it? If this much thought and engineering goes into something as simple as the paint on our walls, what other hidden complexities are we all overlooking every single day?